Hey. Okay. Hey, I'm sorry for all that. Get everybody on board now. Okay. Now, hey, real quick, open up your email. I sent you an email. I had to restart my computer. I'm sorry. Who's got the dog?
James, mute your mic.
Yes. All right. So I wonder if we have everybody or not. Hopefully we do. All right. So, hey, again, hey, I'm sorry for the problems. I had to restart my computer. All right. So, would you guys open up your email real quick? What I want you to do is I want to take you through how to work a couple problems real fast. And then I'm going to let you work on a worksheet. We can work on it together. You're going to submit it, and then we'll be done. Okay. Annabelle is trying to get back in. Okay. Hey, so open up the one that says worksheet number 1, and then open next to it the one that says worksheet number 1 with answers. Okay. You see that? Gracie's like, yep, I see it. We got all the ladies here. We're missing Hayden, right? Let me see. Is Connor here? No, there's Connor up there. Couldn't see it through your window. Okay, so ready? I'm just going to take you through a couple common kinds of dynamic problems. Okay, so the first problem, Connor, would you read this one, please?
All right. Connor decided to pursue his lifelong dream of becoming a paratrooper. He's not very heavy, so he will just drift down nice and slow. Suppose Connor weighs 140 pounds. Calculate what his force of weight would be in newtons. Remember that you have to first convert the pounds to kilograms. 2.2 pounds equals 1 kilogram. Remember to use the method and include your units on all answers and given data.
Thanks. Jace, you look like a turtle. I can't see your face. There you go. Hey, Jace, how do you calculate the force of weight? FW equals... Hit your space bar. FW equals...
mg.
That's good. Okay, hey, Evan Yang, what does M stand for? What?
Mass.
Okay, does it have to be in grams or kilograms?
Mass.
Okay, grams or kilograms?
In kilograms.
It's got to be in kilograms if you're going to use Newton's second law. Okay, hey, Alex Wunderlich, what does G stand for? FW equals mg. What is G? 9. Alex, 9.
9.8.
9.8 meters per second squared. Good. All right. So a lot of questions that are dynamics questions, they use this equation. Okay. So this first equation is we're gonna see how heavy Connor is, how hard he's being pulled down to the earth. You got to use kilograms though. So if Connor weighs 140 pounds, and a lot of you are about that weight, if you take the 140 divided by 2.2, then that'll be his kilograms. Okay. And hopefully you have it side by side right now where you have the blank sheet and the one with the answers. Okay, so anyway, that's about like 65.4 kilograms, right? Okay, yeah, Price.
Are we on chapter 3 problems?
Yeah, problem set 1. Worksheet number 1.
All right, thank you.
Yeah. All right, so FW equals mg. So all you do is you take the 65.4, I think is what it was, times 9.8. And then that would be his weight. So FW equals mg. So it's going to be, I think, is it 641? Okay. Hey, what are the units of forces? All forces, Gracie. Named after Sir Isaac. Spacebar.
Newton.
That is right. Good job, Gracie. So all forces are measured in newtons, okay? So therefore, that's how to find the force of weight. Okay, question number 2. Aya, would you read that, please?
If Connor's acceleration as he floats down is 0.685 meters per second squared, what is the net force acting on him?
Okay, so
Remember
here's,
Connor's method.
thank you, ma'am. All right, so here's the second one. You guys, oftentimes when you work in dynamics problems, you have to use FNet equals MA. Okay, so what is FNet? Remember we talked about hamburgers? If you buy hamburgers for 50 cents and sell them for $2, the net profit is $1.50. So it would be like this minus this. In the same way, it's like this minus this. If you have the force of weight down and like the force of air friction up, you can subtract them. In this second question, we're trying to find the whole net force. So you just go like this, F net equals MA. So use the method, and you know that M is, for Connor, is 65.4 kilograms. I think the A was 0.685 meters per second squared. So you're just gonna go F net equals MA. So 65.4 times 0.685, that's the net force. Was it 41 newtons, something like that? 41? Is that right, Annabelle? That's right. Okay. Hey, last question. Number 3. And after this, I'm going to let you work on this worksheet. And then as soon as you're done, you can leave. So last question, number 3. It says that Connor is going down, and we want to find out how much air friction is going up to make him, go at that rate. Do you see that little picture of Connor hanging on the parachute? You see that? Okay, you see the downward arrow right there, the force of weight? That's 641. The upward arrow is the air friction, which we want. Okay, so now go like this. Oh, Hayden's here. There's Hayden. Okay, so go like this. F net equals MA. So F net, remember the hamburgers. In this case, it would be the force of weight, which is winning, minus the force of friction that's up, is equal to the mass times the acceleration. So FW is 641 minus FF, which is what we want, is equal to Connor's mass, which is 65.4, times his acceleration, which is 0.685. Are you with me on this? So you just do the algebra, and what's going to happen is you'll subtract 641 from both sides, and then what's left over is the air friction. I think it was 596. Okay, so now I got this point. Let me see. Avery in the first class, she goes, how does this relate to the net force? Okay, what was the answer to number 2? 41?
45.
What is it? 45?
45.
Okay, so think about this. Isn't 641 minus 596, isn't that 45? See this? That's 45. That's the net force. Okay, now, hey, everybody, open up worksheet number 5. It's in your email. All you have to do is finish this, put it in Schoology, and then you're done with class, okay? All right, here we go. So the first question is about you and your car. So you're supposed to find the weight of your car. Do cars weigh a lot?
Yes.
Hey, so we had a poll question in the last class period, or the period before. How many of you guys have actually hit something in a car yet? Have you been driving? Okay, Hayden has. Was it like when you were backing out of the garage? Hayden actually went into the garage too fast and ran over his trash can and hit the wall.
I thought you were talking about if like you were in the car when the car got hit, but
When you were driving,
No.
have you hit something yet?
not yet.
Okay. It will probably happen. All right, so here we go. The first one, use the method. So write your given and your want. Okay, and so when you do this, it says you have a car. How much does the car, what's the mass of the car?
$2,200 kilograms.
Okay, so it says, what does the car weigh? FW equals
MG.
mg. So what is g? You can write that in the given. 9. Alex?
9.8.
There you go. 9.8 meters per second squared. And you want FW, right? So don't you just multiply them together?
Mhm.
Hey, Gracie, what are the units of force? Sir Isaac
Newton.
Newton. Yeah, so put newtons on there. Remember, draw a box around it. You just got 5 points.
What do? You just multiply 2200 times 9.8.
Mm-hmm. See, you know what you do in physics, Lucas? So many things in physics are just putting numbers in equations. We have these equations like tools, and you just plug those numbers in, and then out comes the right answer. So FW equals mg. You just take mass times g. Okay, let's look at question number 2. Hey, James, would you read question number 2 for us, please?
Of course.
Thank you.
Suppose that Christina hit a 58.5 gram tennis ball with a force of 125 newtons. What is the acceleration? What acceleration would this give the ball? If the ball started from rest, how fast would it be going if the tennis racket was in contact for 0.14 seconds?
There you go. Thanks. Okay, so let's write this stuff down. Do your little given and want. Okay, did you know tennis balls have a certain mass, just like baseballs do, right, Connor? So tennis balls have a mass of 58.5 grams. That's exactly how they're supposed to have a mass of. But we can't use grams, can we? We got to use kilograms. So write down M equals 0.0585 kilograms. Okay, now then I just made this problem up, and it's kind of unrealistic. It's going to be like she's going to be hitting it too hard, but that's okay. So the next thing says she hits it with a force of 125 newtons. So what is that? What do I write down in the given?
FW?
No, just F, because this is not up and down. This is like side to side. She's hitting it like this. Okay, FW only works up and down with the force of the earth pulling you down. All right, so force is 125 newtons. Okay, then it says, what was the what of the ball?
Acceleration.
Acceleration.
Good. Okay, so then write down in given, in the want column, write down A. Okay. All right, now, hey, you know that equation, F net equals ma? Write that down. F net equals ma. Plug your numbers in. So what's our math that we're going to do here, the algebra? We're going to take what? Are we going to divide something or multiply?
Divide.
Divide. You're going to take the force and you're going to divide it by the mass to get the acceleration. And it's going to be really high. I don't know if there's anybody in the world that can hit a ball this hard. Like I said, I just made it up. All right. So what kind of answer are you guys getting?
230.
2,136.
Yeah, it's in the thousands. It's not 200 something. It's in the thousands. Okay. So check your calculator. Aya.
How do you get that number? Like, what do you do?
Okay. Did you write down F net equals ma? Okay.
Yeah.
So write F net. The only force acting on it would just be the 125. Okay. So that is the net force. So it'd be 125 is equal to 0.0585 A. And you're going to divide through by 0.0585. Annabelle, you held your calculator up.
Yeah, I got like 2,136. Is that what other people got?
Good. Yeah, I think that's right.
That's it. And then it has a lot of numbers after that. So.
Well, there's 3 sig figs, so you could probably say 2,140, couldn't you?
Mm-hmm.
So isn't it 125 divided by 0.585?
0.0585.
Yeah. Oh wait, 0.05.
Yeah. Mm-hmm. All right. So then, hey, the next thing is, it says, let's see if you remember this. It says, if the ball starts from rest, what does that mean?
VI.
Yeah. VI is equal to
0.
0. So write down VI equals 0. And then it says, how fast would it be going? So what do we want to know? What's the given? We want VF. Okay. if the tennis racket stayed in contact with the ball 0.14 seconds. What is 0.14 seconds?
Force? No.
Okay, seconds. Is it a velocity, a time?
Time.
Acceleration? It's a
Time.
time, yeah. Now, okay, who remembers the equation? VF equals VI plus
AT.
AT. Write that down. Good, Lucas. Good job, Lucas. VF equals VI plus AT. So from this
So we're
point
doing
on,
another equation on the same thing.
yeah, it's on the same thing, on the same little given and one. So on this, at this point right now, I think you could probably finish it, can't you? As soon as you got it and turned it in, then that would be great. You turn it in via Schoology, please. If you're having trouble, and because I'm recording this, I think what I'm going to do is I'm going to show you how to do this too. Okay? This is for maybe if you're feeling like you're a little bit lost. And then also for the people that are going to watch this on video, because there's some people that forgot to come to class today. Where's my stupid stuff? Physical science. Here it is. Sorry, I got lost there. Pretty soon I'm going to have you guys running up and down stairs to find out how much horsepower you have.
I don't have stairs.
You don't have stairs.
I have 3 stairs.
You only have 3 stairs. That's not enough to do that.
Lucas, you
Where
can
could we
come to
find
my
you
house
some
and do it.
stairs?
I don't know.
Lucas
We
can
could
come
have
to
you
my
go
house
to
and do
the
it.
bleachers, I guess. All right, so here we go. I'm going to work the second one first, okay?
Wait, I have a question for the second one. Is our answer
Okay.
gonna be what unit is our answer gonna be in for the second one? Or
It's VF, so it would be meters per second.
yeah, okay, thank you.
Okay, so on this one is given want force is 125 newtons. The mass was 0.0585 kilograms. We want the acceleration, so you'd go F net equals MA. And so you'd go 125 equals 0.0585 A. And A would be equal to, was it 2,140, you guys? Is that right?
2,136.
Okay. So draw a box around it. I don't know if you're looking at my screen or not. Did I share my screen? I shared my screen with you. Then you go like this. You go VF equals VI plus AT. And when you read the problem, the VI is 0. You want the VF. The T was 0.14 seconds. So then you'd go VF equals 0 plus 2,140 times 0.14, like that. So you're going to get a big number. What did you guys all get?
299.6.
Okay.
300.
So basically like 300.
Yeah, 299.
Okay, so if you wanted to say 300 though, you're going to have to go like that. Whoops, I'm sorry. You're going to put a bar over that 0. Or you
Wait,
could
so what's
go
the units again?
3.0 times 10, my bad. Not like that. 3.00 times 10 to the second, meters per second. All of those I would take as being right. Okay? Does anybody else have any questions? If you want to stay on and ask me more questions about this, you can. Remember, you can put it in Schoology. Hey, what is the best score anybody has gotten on Lunar Lander today as of yet?
I got
That's
90.
you today, isn't it?
75.
Huh?
75.
75 is good. Hey,
Got 90.
Gracie, what'd you get?
15.
That's okay. Hey, did you see the International Space Station?
Yeah, but my dad didn't take a picture of it. He used
Yeah.
flash and it was the black picture, so.
All right. Maybe if you do terrible on the lunar lander thing, if we can get you to find the space station, maybe I could catch a little slack and give you the rest of those points. Okay. But you're supposed to clip that and snip that in today. Okay. All right. I'm going to turn the recording off now.